Hey guys, so this is my first of a series of videos on solubility and solubility products, aka solubility stuff. Now, there's 4 or 5 main things you need to be able to do in the AP exam regarding solubility. The first of it is writing balanced equations and using equilibrium expressions for dissolving substances, dissolving ionic substances. Now, first thing I want to tell you is there's a link between solubility products, generally speaking of salts, and weak acids. So a weak acid, Ha, dissociates like this into a cation and an anion. A salt in its solid form, so you're always going to start with a salt which is S, solid here, dissociates into a cation and an anion as well. Note that equilibrium expressions, however, are different. Remember, equilibrium only includes things that have changeable concentrations, so gas and aqueous substances only. As a result, when you dissolve salts, the equilibrium expression only contains the ions that are produced after dissolving. So, let's have a look at some common substances, some common ionic salts, and you can see for yourself how you write the balanced equation and write the equilibrium expression. I've left these blank so that you can have a go practicing it yourself, and then I'll put the answers maybe in the YouTube description. You can see if you got it right or not. So first thing, we have Pb, lead, PO4, phosphate, lead, phosphate. Now the key thing to note are these numbers here, 1 and 2. Because this is number 3, this is number 2, it means that every one molecule of this substance includes 3 molecules or ions of lead and 2 ions of phosphate. So when it dissolves, you're going to make 3 Pb2 plus and 2 PO4 2 minus. You have to be able to turn this substance into a balanced chemical equation. Okay. Now, as to whether or not or how you would know what charges these ions would be, I recommend using the periodic table as much as possible. So you'll see that some substances are in some groups. For example, you might see that magnesium in group 2, so you know it must be an Mg2+. Otherwise, it does take some practice and some basic memorization of what charges different ions form, okay? So, you show the dissolving of lead phosphate like this. Now, for something like nickel carbonate, I've shown here instead the solubility product, the equilibrium expression. So KSP equals the nickel 2 plus ion concentration times the carbonate 2 minus ion concentration. Note that because the ratios of ions to each other are 1 to 1, in my equilibrium expression, the concentrations are also 1 to 1. That is definitely going to be different for this one. So when you guys have a go at doing that, please keep that in your mind. Also to note, and I've given you another example here of iron oxalate dissolving, and I want you to have a go writing the equilibrium expression for this. Please note that you need to take the coefficients of the ions up to the power here when you write the equilibrium expressions. And then when it comes to making an ice table to note how concentrations have changed, you also need to keep in mind that when your ratio of ions is 1 to 1, you can expect to have an X and an X or an X squared value for your KSP. If you remember what we did with weak acids, this was very similar. So you have H plus A minus. Because the concentrations of both ions are identical, you can only have a H plus if you also have an A minus. You always had X squared on top of this fraction. It is the same when you have ionic substances which are 1 to 1, but for many of these salts, the ionic ratios are not 1 to 1. So you do end up with some reasonably large powers of X. You might end up with to the power of 3 or 4 or 5. That's nothing to be scared of. You just need to solve it in exactly the same way as you always do. So, balanced equations and equilibrium expressions. This is one big part of solubility products.